collector, and he has even done a lot of things in locomotion, probability theory, and he was a great philosopher and even a religious figure. So at age of 16, he has made something very great. He has done something great which has stirred astonishment at entire mathematics community. So he has published an essay, something like one page, it was a result which is known as Pascal's hexagon, Mystic's hexagon. So it is like if you inscribe, if a hexagon is inscribed in a conic section, then the points where the opposite sides meets are collinear. These results were very outstanding at that time. So some sorts of envy was also developed in many mathematicians, like Descartes was quite envious of this result because at small age he was doing such a great thing. So this is some sort of human nature which is reflected. And even he has done very nice thing in Pascal's triangle. This triangle is not very new, even Indians and Chinese were using it, but Pascal was the first person who had taken a lot of new things from it. Such a good insight he has. So Pascal's entire journey of mathematics can be divided into two parts. The first part was how he invested a lot of time in developing the skills of mathematics, giving a lot of new mathematics to the world, and other things is the spiritual side. But this spiritual side which I want to reflect is that he has suffered an accident, and after that, after just 2 months, he writes that there is a dramatic encounter with God on November 23 in 1654, and he wrote his experience and sewed it in his coat, and wherever he used to go, he used to carry this. So this encounter has become known as Pascal's Night of Fire, and this encounter has changed his entire life. Something like after that, after this memorial, he refrained, he stopped his, some sort of renunciation was developed in his life, and he refrained from publishing mathematical treatises which are already published. And also, during his lifetime, nothing more appeared under his name. So such an encounter with God or with divine has changed his entire lifetime, and then he started using his mathematical skills to glorify Lord or glorify the divine. The first thing which he has used, like he has done a lot of probability calculus, so he has used this skill to write up Pascal's wager, and that is, if God does not exist and you believe, then you are at a finite cost. If God does not exist and if you don't believe, there is a finite gain. But if God exists and you believe, then there would be infinite joy. And if God exists and you don't believe, then there would be infinite pain. So a mathematician from University of Wisconsin has told that Pascal is not trying to convince you that God exists, but he is trying to convince you that it would be to your benefit to believe so. Pascal argued that we don't need any actual estimate for the probability that God exists, so long as the probability is non-zero. Even if there is only a 1 in a trillion chance for the existence of God, 1 in a trillion times infinity is still infinity. Regardless of what assumption we use, Pascal's wager and the counter arguments against it are wonderful examples of using mathematical thinking, considering probabilities and outcomes to wrestle with deep philosophical questions. So this is the example of how we can use our mathematics to go deep and deep into that philosophical questions. So second thing is that Pascal even wrote in his book, The Art of Persuasions, where he looked deeper into that axiomatic method of thinking. For example, why we consider axioms. There is no proof for any axioms, but how it comes to any human mind. So Pascal agreed that achieving certainty in these axioms and conclusion through human method is impossible. For example, there are so many postulates of Einstein and all this stuff. So he asserted that this principle can be grasped only through intuition, and that this fact emphasized the necessity for the submission to God in search of truth. Even the mathematical concept of infinity, Pascal has done a lot of work for the summation of series and infinity and all this stuff. So he was very familiar to infinity, and whenever he used to think of this, automatically the infinite nature of God comes into his mind, and he start thinking, when he thinks also the limited possibilities of a human existence. So there is he used to we got in detailed into this. Human beings are mysteriously suspended between two infinities. Unity added to infinity in no ways increases it. And to Pascal, it is perhaps the clearest indication of the existence of infinite being. So also, Pascal's also done a lot of experiments in vacuum. So at that time, existence of vacuum is anti-Aristotelian, because why there should not be nothing, there should be something. But Pascal was the first person who proved experimentally that there is some sort of vacuum also. And his experiments with vacuum led to several important insights that contributed to theology and science, including the emerging mechanical view of nature that replaced the mysterious invisible substance that has filled the empty space of Aristotle's universe. Being the very reverse of new Aristotelian, he sees no contradiction between belief in vacuum and God. So once Descartes came to Huygens and wrote a letter to Pascal, that he also told that there is vacuum inside this Pascal's head after he doesn't. So there are so many contradictions between this physicist and mathematician at that time. So Pascal had to fight a lot, and lastly Aristotle also said that there should not be any vacuum vacuum in nature. Nature doesn't allow vacuum. So, but experimentally he proved it that there is some sorts of vacuum. And this Pascal doesn't believe that if you believe in vacuum, God is same thing. Means it's not like you are going towards the truth. So why you are being so biased, something like. So at last Pascal regarded faith in God as a basic axiom from which all certain knowledge proceeds. So that's all. Thank you.
Thank you so much, Shri Roshan Tiwari. Let's give a round of applause for Roshan. He did a great job, young, talented, and of course a college boy. So after this vision, now it's time to move on to the next, and the next topic is mathematics and poetry. For that, would like to welcome to the dais Dr. Ramjee Repaka from Indian Institute of Technology, Ropar. Let's welcome Dr. Ramjee. Would like to request you, please have a round of applause and let's welcome. Thank you very much, sir.
Yeah, thank you very much. So, welcome you all to this August gathering, and then very nice deliberations are going on. So, just to keep you everything from the boring somewhat, if somebody says mathematics, it's sort of boring for the normal layman who is not a mathematician. So, just I'm trying to bring something which is mathematics and poetry, something deviate from what you have been seeing from the last few hours. Sorry. So I will invoke this with Srinivas Iyengar Ramanujan. FRS, a statement, an equation has no meaning for me unless it expresses a thought of God. So not only this, if you see at the Vedic ancient Indian culture, and if you see that everything is depending on an anchoring point, so where you see that the mathematics also played an important role in that, and it has been understood, and even he has realized that something, the God needs to be invoked every time. And the most distinct and beautiful statement of any truth must take at last the mathematical form. So this was told by the American essayist poet, the Henry David, and few more. So what after all is mathematics but the poetry of the mind, and what is poetry but the mathematics of the heart? So it was told by David Eugen, an American mathematician and educator, and a mathematician who is not at the same time something of a poet will never be a full mathematician. Of course, no offenses to any mathematicians here, and this was told by German mathematician Karl. Well, if you see, just I said in the starting of my presentation, something different from what you have been seeing from the start of the day. So if you see how you can express everything, as engineers and the scientists, so if you wanted to express some physical aspect To make understand everyone, including mathematicians, you try to represent that in form of equations. So equations are better understood by anyone if they have the basic knowledge of that. So this is how, if you see, a person can have an infinite love if his ego is tending towards 0. And this is the classical one, you know, the limit tending to delta x tending to 0, then anything, the curved line becomes a straight line. So from that only it has been derived. And is Kaz Maslanka, he has told, an engineer and a mathematical poet. He is basically an engineer. So a crude translation in case you have forgotten your limits, what it says, the love becomes infinite as the ego becomes 0 or vanishes. And another mathematician, he is an ex-professor of mathematics at Georgetown University, Washington, Professor Ray Bobo. He says, give me an epsilon and I will treat it well. So what it says, if you see, x is equal to phi, phi is within the brackets, and then there is an epsilon which he has told, give me the epsilon, and then x plus y tends to infinity. Of course, it's very vague and then very dry to see, but he has given the explanation. Please hold your breath. And here it says, so found alone and wanting, I now languish, what? Unbegun. So it has not yet started. And it says, oh, to have your arms about me, be transformed into the one. So this is the meaning for the first two lines of mathematics representation, and says, closeness for our angels is returned with an embrace, and so that by incorporation we can soar to loving space. So it says, just now we had a presentation by earlier speaker about the infinity. So this infinity really it goes to what extent, there is no limit for that. And in meaningful, in asking all, amen. So this was told by, if you see how you are representing the mathematics, but you see at the end, if you are coming out with 0 ego, then it will be really infinite love. And there was a small treatise, small stanzas, 3 stanzas wrote by the Frederick Soddy. He is a fellow of Royal Society and Nobel laureate in chemistry. He is not an engineer, but he is a chemist, but he has wrote nice paragraph. I'm showing you what it is, keeping the time in view. For pairs of lips to kiss maybe involves no trigonometry. This not so when 4 circles kiss. Well, each one the other 3. What it says, this is what? Not the romantic love, it's only the mathematics love, the love for mathematics. Well, and it says to bring this off, the 4 must be as 3 in 1 or 1 in 3. So 3 in 1 or 1 in 3, it comes out, so 1 in 3. So this is what? 1 in 3. And in 1 in 3, beyond a doubt, each gets 3 kisses from without. If there in 1, then is that one 3 kissed internally. So if you see, these 3 are getting kissed internally. This is what the kissing means here, nothing else. So 4 circles to the kissing come, the smaller are the bender, the bend is just the inverse of the distance from the center. So what it is being mentioned in the mathematics, you see, the bend is basically inverse of the radius of each circle, and it is being denoted by B1, B2, B3, B4, and then R1, R2, R3, R4 respectively. And though their intrigue left Euclid dumb, and there is now no need for rule of thumb, since 0 bends a dead straight line and concave bends have minus sign. So basically they are trying to draw a tangent for all these 3 circles, and they are trying to find another circle. The sum of the squares of all 4 bends is half the square of their sum. So what is it? So this is what? Sum of the squares of all these 4 bends are basically inverse of the respective radii, and then it is giving you half of the sum of the bends and its square. And the third one says, to spy out spherical affairs, an oscular surveyor, basically oscular means it's about kisses, and might find the task laborious. The sphere is much the gear, and now besides the pair of pairs, a 5th sphere in the kissing shares. What is the 5th sphere? If you see 1, 2, 3, the big circle, the 4th, and then in between the circle represented by the red color is the 5th sphere. So what it says, a 5th sphere in the kissing shares, yet signs and 0 as before, for each to kiss the other 4, the square of the sum of all 5 bends is thrice the sum of the squares. This is what? The square of all the 5 bends is 1/3 of the sum of the bends, which is square. So this was told by Frederick Soddy, And it is about the Vincent Millay, and actually she is an American poet and playwright, and then she got the Pulitzer Prize winner in the year 1923. It says, Euclid alone has looked on beauty bare, and of course, really time is running out, just I will try to read few points. What it says, let geese gabble and hiss, but heroes seek release from dusty bondage into luminous air. Oh blinding hour, oh holy, the terrible day. The holy terrible day is actually reflecting into the day on which that Jesus Christ is being slayed on. Well, whole light anatomized, Euclid alone has looked on beauty bare. So he is seeing, actually this is representing actually the trigonometry, the area in which you are trying to make a trigonometry. Fortunate they who, though once only had them but far away, have heard her massive sandals set untune. So this is being told about the nature. And the last one, the Pi is a mathematician and poet. He says about the imaginary numbers. So he says a real life ends but is imagined by those left behind, and imagined death comes reality. So death is the real one eventually, of course. And the square root of -1 can't exist since a squared number can't be negative. But imaginary numbers yield real answers in the real world. So whatever the imaginary things which we see in mathematics, they have some reflection to your real life. And imagination, a false oasis that burns, shimmers and melts away before my eyes. When you keep on walking over the deserts, in the far you see there is water body, it's oasis. But when you go near, it got shimmed away. So there is nothing like there is a water body. So this is what it says, this is the reality in our life. Yeah. And I thank, and then with deep sense of gratitude, and then I give my acknowledgements to Dr. T.D. Singh. He is my spiritual master, His Holiness Bhakti Swarup Damodar Swami. And also it was inspired by one of my god brother, Mr. Varun Agrawal, the Brajendra Kumar Das. So that is why I could start this thing. Thank you very much for your patience.
Thank you very much.
There are no questions for this.
Thank you very much for the wonderful discussion about the topic. We're going to move ahead. Would like to request, so please kindly move forward. Thank you.
Thank you. We have now test. We have now come to our third session, titled Mathematics, Life and Nature. So we have 4 eminent speakers who will be speaking on this topic, and they have 40 minutes to present, including questions and answers. So first up, I'd like to invite Professor Pier Luigi, Professor Emeritus, ETH at Zurich. I'd like to read a small introduction to Professor Pier Luigi. Professor Pier Luigi received his scientific education at the Scuola Normale Superiore in Pisa, Italy. In 1970, he became professor at the Institute für Polymer at ETH Zurich, and since 2006, he's part of the biology department of the University of Roma III. As a biochemist, he pioneered an active research in the self-organization of synthetic and biological systems, the origin of life, and semi-synthetic cellular systems, the so-called minimal life. Interested in the interface between science and humanities, in 1985 he founded Cortona Week, legacy to this Toddy Week, and participated in 1987 to the foundation of Mind and Life in Dharamsala, India, with Francisco Varela and the Dalai Lama. Put your hands together to welcome Professor Pier Luigi.
Thank you very much, and I would like to express first my gratitude to the organizer for this very beautiful setting and organization, and for the honor of being here. I am not a mathematician, I am a bioscientist, and the title, it's a little preposterous. I will talk what is life in terms of science. Life is, of course, a subject a beautiful one also for artists. And there was upon a time in which each waterfall, each spring, each cloud was life. We abandoned this beautiful terrain to remain in science, and I will present in this non-poetic scenario for a very quick view of this science with the question, what is life? And the first thing, of course, is to say, what is life? And, to realize we are now here at the edge of the, oh no. Yes. Of the Milky Way in a very uninteresting place. And here there is a little star which we call Sun. And close by there is a little grain of sand that we call Earth with a little water. And as far as we know, life is only limited here. There is no other place for science where life exists. Of course, here is where my struggle as a biochemist begins with my friends, mathematicians, particularly the statistician, where they begin to say, look, there are so many galaxies, and each galaxy contains billions of stars. So if there are billions of stars, of course, there will be millions of places where there is life. And, but, I am a little cautious with this kind of view. And yes, I realize as a scientist, actually, that there are many questions we are not able to address, or address, yes, but to tackle with. And you remember the famous, if you look at these billions of galaxies, each containing billions of stars, and then you think of these mysteries of the dark energy, of the dark matter and infinity, you end up with these very famous and unsolvable questions of Leibniz and Heidegger, why there is something instead of nothing, which I like to present also to my students as one question which science cannot answer, and is perhaps good so. If you want to answer this question, you have to go into a very personal pathway, and science does not matter any longer. And this is something that came to my mind, thinking of these very many mysteries we are not able to tackle. And once as a boy, I was on my computer and I saw a little ant crossing my television set, actually my computer, and I thought that this ant will never be able to understand the complexity of a television or of my computer. Is something order of magnitude above the capability, the cognitive capability of these things. And then when I look at these pictures, for example, of the little man who goes up to the sky with his little base spaceship, I, came to think that there is some kind of analogy. But going back to my friend statistician, and there is no doubt that modern astronomers have discovered several thousand of planets in the so-called habitable zone. And here there are, for example, some of the most famous of these planets, which are, this is the Earth, so they are very comparable, and they, my friend astronomer, claimed that maybe there is some water, and perhaps there is some form of life. And actually, if you look at these data of...
Excuse me, Professor. When you change the slide, show that side, because your slide...
I should say that?
No, no. When you change the slide, point there, because slide changes the direction.
Oh, okay. Thank you very much. One learn always something new. So this idea that there are as many as 40 billion Earth-sized planets orbiting, and then my friend astronomer, whom I like to struggle often, they say, well, of course, then there are many millions places where there will be life. And here is the time to mention the Fermi Paradox. When he was confronted with this idea, say, look, there are so many possible other stars and planets, and there will be many, many forms of life. They say, yeah, where are they? You know, the famous Fermi Paradox. And in fact, I think this is not a real serious paradox. The question, where is everybody, can be understood on the basis of some simple mathematical, formulation. For having aliens talking with us or having signal with us, you have to have two planets or more planets which are similar in terms of evolution. There is no sense in talking about possible communication between or among planets which are 100 million years away from each other. Remember that 10 million years ago there was no intelligent life on this Earth. So that if you ask the conditions for planets which are similar or have a kind of quasi-simultaneity in terms of cosmic evolution, and also you want that they are at a manageable distance, even considering, you know, the speed of light, you don't find anything. And so this question, where is everybody, maybe they are someplace, but it's impossible for us to talk to them and to know whether they are there. To me, the old question by Monod, are we alone in the universe, does not, I have nothing against this idea. I know that many people don't like it, but I am ready to bet that all these people who say, yes, there is life, this is not a scientific statement, but it's a kind of faith, maybe a beautiful one, alimented by science fiction and our beautiful mind, but in terms of real science, we are still alone in the universe. No problem for me. But now let's go down again and back with the question, what is life in terms of science? Now, for that, let me, I should point here. Yes, let's see the scientific thinking in our age from the last century on. I pass all the kind of mechanistic thinking of Descartes and Newton and Galileo with their mechanistic view according to which the living was a machine, and all their analysis was the so-called analytical procedure by which, if you have a complex system, you divide this complex system in many simple ones. You take one part, you study the part, the second part, the third part. You put all this information together with the idea, with the hope to get then the truth of the system. But this, in this age, a series of thinkers, mostly independent from one another, like von Neumann and Bateson and Förster and Alan Turing and Wiener, etc., began to formulate new ideas against the mechanistic view, emphasizing holistic complexity, system thinking, and collective properties, non-linearity, new concepts. And the very simple question to start with is this one. You see, it's a simple butterfly, and yes, you can study the wing, which is kind of silky material. You can study the antenna, which is a kind of gelatinous keratinoid material. The body is gel-like. Yes, many different, but how all these different parts know that they belong to the same entity? You know, this very simple question produce a kind of collapse of the all mechanistic thinking, and actually gave rise to this kind of system view. Here my book with Capra, but before us there was von Bertalanffy, with this idea that very important, and which is the basis of, I believe, the paradigm today, is that if you look at a very complex system like, you know, the man formed by so many different parts, and actually to simplify things, let me show the organ, the brain, the liver, the lungs, the kidneys, and these arrows are not the fantasies of my artistic friends who made these slides for me, but they are physiological realities, as the intestine cannot do its own business without having contact with the stomach or the liver, and the heart cannot beat its number of beats independently of, you know, all what other organs do. This is like an orchestra where the various players, in order to produce a meaningful, beautiful harmony, have to be in tune with each other. Nobody can do its own business. It's a kind of touching and hearing, and life is this kind of integration of many different things. And of course, there is also, and this can be, yes, can be the different organs, but can be the different cities of a nation, or can be the different nation in our world, can be the different members of a party, which, you know, in order to be one, they have to interact with each other. And if then you begin to cut all these links, you find something that we call death. Death is, you know, you can still have all organs. If here there is a horse which died, is just dead, this dead horse has all proteins, all DNA, all blood, all hormones of the living one. Why do you call it dead. You call it dead because although it has all organs, they are not connected with each other. This is death, which is a picture of fragmentation. Dead is fragmentation, and life is connectivity. Okay, then there will be something to discuss here which I cannot do because the argument of life versus death will be very big question, and I have given several dialogue with religious men, and I am a student of the origin of life, and the origin of life has never been a big problem between science and believers. There is many ways to find a hug about that, but